All right, my math magicians, this is section 4.12, Polynomial Functions and Modeling Day 2. The big idea for today is that there's a relationship between zeros and intercepts and solutions. So if you can find the zeros, then you've got the intercepts and you've got the solutions. They're very related. In fact, they're so related that students often confuse the two because they mean the same things often. So let's find the zeros of factored polynomial functions. So here we can see the question is, if you're given a polynomial like this, are 2 and negative 5 zeros? So in other words, when you substitute 2 for x, do you get 0? Or when you substitute negative 5, do you get 0? And you can see that when we do, we get p of 2 is all this, 2 cubed, 2 squared minus 17 times 2 plus 15. And then when you actually add them all up, you get negative 7, which is not equal to 0. So the answer is no. For the first one, it is not. Let's see what else happens. If you plug in negative 5, is negative 5 a 0? Well, when you substitute negative 5 into the function, you get negative 5 cubed plus negative 5 squared minus 17 times negative 5 plus 15. You compute all that out, and you get 0. And then you can say, yes! Yes, it is a 0, because negative 5 is a 0. It produces 0 in the function. And you can see that graphically here. Zeros, here's the big idea. Zeros is the same thing as intercepts. Zeros will give you the intercepts. Is 2 a 0? Well, when you look at it here, when x is equal to 2, nope, it's not an intercept. But negative 5, yes, negative 5 is an intercept. You should also be able to find that 1 and 3 are also zeros as well. You should be able to verify just by plugging them in. Here, find the zeros of f of x is equal to 5x squared, x minus 2 cubed times x plus 1. Well, since it's in factored form, it actually is a lot easier, because if we can find the solutions, as we're about to do, of f of x equal to 0, then we can say that those solutions would be zeros, and they'd also be intercepts. Zeros, intercepts, solutions, they're all the same. So you can see here, if we're going to solve this, then we can split it up into the different parts using that theorem. So we get x minus 2. From here, x minus 2 is equal to 0, so x equals 2 is a 0. It's a solution, and therefore is 0. And then x equals negative 1. And there they are. These are the solutions, and so therefore they're also solutions of the polynomial equation, so therefore they're also the intercepts on the graph and the zeros of the function. If you were to say, what is f of 2? It would be 0. What is f of negative 1? It would be 0. We found the two zeros by solving the polynomial equation. Find the zeros of this one right here, g of x. Well, if we create a related function, the related function would just be equal to 0, and then we have to solve it. Here, x minus 1 is equal to 0, and x plus 2 would be equal to 0. When you solve those, you get x is equal to negative 1. So the zeros are negative 1 and negative 2. There's this idea also of multiplicity, like how many times does it occur? And so what you can do is you get the multiplicity from the exponents. How many times is this a 0? Actually, this should be a positive 1, shouldn't it? Positive 1. How many times is this here going to be represented as a 0? It'll be represented as twice. That's its multiplicity. Because you can write it out 2 times. Technically, if you wanted to, you could write this as negative x minus 1 times x minus 1. It occurs twice. X plus 2. X plus 2. It's kind of a duplicate 0, because it occurs twice. How many times? 2. 2. to talk about multiplicity back up here, you could say that this 0 has a multiplicity of 3. Has a multiplicity of 3, and this has a multiplicity of 1, because it only occurs one time. Whoa. Okay, so even and odd multiplicity. If x minus c, and c is the 0, to the k power, where k is greater than or equal to 1, then you can say that it's a factor of polynomial function p of x, and x minus c to the k plus 1 is not a factor. And k is odd, as it is here, and the graph crosses the x-axis at c comma 0. If k is even, then the graph is tangent to the x-axis at c equals 0. So if you know the multiplicity, then you can see whether or not the graph just is tangent, or crosses. So if your multiplicity is odd, that's what k is. K is representing the multiplicity. If the multiplicity is odd, it will cross. And if the multiplicity is odd, it will cross. If the multiplicity is even, it will be tangent. It will just barely touch the x-axis at only one point. By the way, I've never been to Moscow, Russia, but that's your audio check for today. If you've been to Moscow, Russia, it's where the Olympics are and have been. So let me know when you get to class. Let's check this out. Let's find the zeros of x cubed minus 2x squared minus 9x plus 18 by factoring. Well, if you can factor, remember one thing that made the previous examples easy was that it was already in factored form. So here, what I'm going to do, I'm going to factor by grouping. And so we can see the greatest common denominator, or greatest common factor, the GCF of these two terms is x squared. Boom, right here. And x squared times x gives me x cubed, and x squared times 2 gives me 2x squared, with a subtraction between. Then here, the greatest common factor is going to be 9. I'm going to factor out a negative 9, so we get minus 9 times x is minus 9x, and minus 9 times minus 2 gives me positive 18. So here I can see that x minus 2 is occurring twice, and I'm going to factor that out, and we just have x squared minus 9 over here. Then I'm going to further factor. We've got a difference of squares. X squared minus 9 gives you x plus 3, x minus 3, x minus 2. So the zeros are plus and minus 3 and 2. We've got all three zeros right here. What that means is if I substitute into the function either positive 3, negative 3, or 2, I should get 0 out. And since they're zeros, they should also be intercepts. Since they're zeros, they should also be intercepts. And look at that. There they are. They are intercepts. And more than that, if you set this equal to 0, then they would be solutions to the related function, or the related equation. All right, let's do another example. Example 5. Find the zeros of f of x is equal to x to the fourth plus 4x squared minus 45 by factoring. And if you wanted to, you could do a u substitution, and the u would be u is equal to x squared, so that u squared would equal x to the fourth. Anyway, regardless of whether or not you do that, you would have this, you'd have to factor it. And factor x, you'd put the middle term here for the negative 45 here, and then you can see that 9 and negative 5 are what you would need here. So once you factor it, then you can see x squared plus 9 is not going to have any real solutions. If it was x squared minus 9, then yeah, you would have some real solutions. You would have x equals plus or minus 3, but you don't, because this is a plus here. We can't go any further. If you were going to allow for imaginary solutions, then you could, but we're only looking for real ones. And so here you can see x squared minus 5 turns into x squared minus 5 equals 0, x squared equals 5, x equals plus or minus the square root of 5. Once we set all of this equal to 0, we've got the related equation to solve, and the solutions are the zeros, which are the intercepts, as you can see. Here are the intercepts. The square root of 5 is 2.236 approximately, and then you've got the zeros right here. Example number 6, find the real zeros of all of this using a graph. Okay, well, we know that they're very related. If you graph the function, then the intercepts are going to be the same thing as the zeros. 1, 2, 3 different intercepts. So the first one is negative 1.68, and then I want you to write down in this list the other two zeros, the other two intercepts. And then once you do that, I'd like you to start 4A2, assignment 4A2, copy the problem list, and do a problem.